In this video, I'll go over the solutions for the 2.1 worksheet. Now for number 1, you're to find the slope of the secant line through the points 1, 3, and 3/2, 6 on the curve f of x equals to 2x squared plus x. Now for this one, I actually did give you the y value, so in some ways I didn't even need to give you the function, because if you were to plug in, let's see, f of 1, you would have 2 times 1 squared plus 1, which would have been that 3, just as we said there. And same thing if you plugged in the 3/2 into the function, that would be 2 times 3/2 squared plus 3/2. So that would have been, let's see, 3/2 squared, that would have been 9/4, times 2, that would have been 9/2, plus 3/2 halves, which would equal to 12/2, which would be 6, which again corresponds to the point that you were given. Now to find the slope of the secant line, the slope would be the function value of when you plug in the 3/2 minus the function value when you plug in the 1 all over the 3/2 minus 1. It would be the change in y's over the change in x. So again, the f of 3/2, that was 6. F of 1, that was 3. And then we have the 3/2 minus 1. So that would be 3 over 3/2 minus 1 would be 1/2. And remember, dividing by a half is the same thing as multiplying by the reciprocal, which would be 2. So that would equal to 6 for the slope of that secant line. Now for the next question, it says an object moves along a coordinate axis so that its position at time t is given by s of t equals to 2t cubed plus 1, and you're to find its average velocity over each of the following time intervals. Now one of the main things I've noticed when I was grading this question is that people were rounding in the middle steps. You should make sure that you do not round until the very end. So the first thing you would do is, in this case, we gave you the two values of t, but we didn't give you the function value. So you'd plug in 2 and 2.5 into the function. So s of 2, that would be 2 times 2 cubed plus 1. So that would be 8 times 2, which would be 16 plus 1. So that would be 17. S of 2.5. So that would be 2 times 2.5 cubed plus 1. And then if you plug that into your calculator, you would have got 32.25 for that. So the average velocity is just like finding the slope of the secant line using these two values to plug into the function. So the average velocity would equal to the value of the position function at 2.5 minus the value of the position function at 2 all over 2.5 minus 2. So that would have been the 32.25 minus 17 over 2.5 minus 2 would have been 0.5. And so let's see, 32.25 minus 17, that would be 15.25 divided by 0.5, which would be the same thing as multiplying by 2. So you'd get 30.5 would be the average velocity if you go from 2 to 2.5. Now what if we did it from 2 to 2.1? Well, the first thing we got to do, we already found what is the position when time was 2, so we got s of 2 already. So we got to find s of 2.1. So that would be the 2 times 2.1 cubed plus 1. So the 2.1 cubed times 2 plus 1, plugging that into your calculator, what you would get is 19.522. So plugging this in, and with these values for t, the average velocity would be, again, the s of 2.1 minus s of 2 all over 2.1 minus 2. So that would be the 19.522 minus that 17 all over 2.1 minus 2 would be 0.1. So that would be 2.522 all over 0.1. And what you would get for the average velocity would be 25.22. Now, doing the last part is just doing it with the value from 2 to 2.001. So once again, what we'd have to do is plug in the 2.001 into the function. So we have 2 times 2.001 cubed plus 1. So I'm going to get my calculator out. So 2.001 cubed times 2 plus 1. I would get, let's see, 17.0240120002. So again, I do not round until the end, the last step. So the average velocity, because when you do it in the middle, the more steps you do afterwards, the more inaccurate your answer gets. So plugging it in, so again it would be the S of 2.001 minus S of 2 all over 2.001 minus 2. So that would be that 17.0240120002 minus 17 all over would be 0.001. So you get 0.0240120002 all over the 0.001. And what you would get from that is 24.012002.